Another interesting question that you can ask is probably what time of day is it? And there are many other questions that you can ask. And this is only related to images, but there are also questions that you can ask relating to videos as well. Like, for example, take this short clip, for example. You might be asking, what are they doing in the video? How would you categorize this video? And if you watch till the end, you would probably want to ask who won the contest as well. Now, for a human, this is quite easy to do. But for a computer, all of these questions is quite complex, and it is quite a challenge for scientists in order to find the right algorithm or the right models to actually answer these kinds of questions. But it is a growing field, and a lot of new algorithms are being implemented every day in order to answer these sort of questions. And so the field of computer vision itself dates back to the 1960s with Larry Roberts, who is now widely considered as the father of computer vision. He published a paper titled "Machine Perception of Three-Dimensional Solids," detailing how a computer can infer 3D objects from 2D image. And his work led many other researchers into the field that we know now is computer vision. And since then, there are multiple approaches to conduct or to do research in computer vision. So traditionally, a lot of the approaches in computer vision involves manually finding some unique features or characteristics that are only present in an object to detect that particular object and recognize it. Now, these kind of approach have some major drawbacks because one major drawback is that an object that the same object can have totally different visual in terms with regards of their sizes, lighting conditions, and so it is hard for scientists or researchers to actually find the correct features that are able to represent that particular object across all different variations. And that led to a new approach of computer vision, which I call the modern approach, which is using convolutional neural networks that are introduced in deep learning. So CNNs allow the features of an object to be extracted automatically, just by showing the networks different variations of that same object. The CNN will be able to learn what features best categorize that particular object. However, this approach does not come without a drawback. It needs a large amount of samples or data in order to be able to have the network learn the right feature. And so these are what I've told you earlier are the overview of computer vision. Now I want to tell you a few reasons that about why you should study computer vision. And the first reason is that there are huge amount of visual data that exist in the world. Just look at these three big companies alone. They have for Facebook, they have over 300 million images and videos uploaded a day, and for Instagram, it's over 55 million images and videos uploaded a day. While on YouTube, there's over 100 hours of videos uploaded every day. So with this huge amount of data, learning computer vision can help companies and particularly those who possess a lot of visual data learn from those data automatically. And those kind of knowledge can yield companies major benefits, major revenues gain. And for small startups like the ones I'm working in right now, we are able to implement some computer vision algorithm in order to benefit society as well. So that is one major reason I think you should learn computer vision. For the second reason is that there are many useful computer vision tasks. There are things like object detection, where you will be able to teach computers to recognize objects and videos in real time. There are also face detection and recognition, where you can teach a computer to find faces in a video and recognize who that face belongs to. There's also optical character recognition, where you can teach a computer to read text from images. Now, this is particularly useful in countries that are digitalizing, such as ours, such as Cambodia, because a lot of documents, particularly in the government, that needed to be digitalized, and so OCR can help a lot with the transition of those documents from a paper-based documents to a digital one. There are also head post estimation, where you able to teach a computer to predict the Euler angle, the angle of the head of a human. This also has major implications as well. People use it in self-driving cars to actually detect whether a passenger, a driver is looking at the road or is paying attention to the road. And it also has some fun application in, for example, Instagram filters, where they put like animal objects, animal head on a human, and that animal head is able to mimic the human head in real time as an Instagram filter. Now, these four are not just the only applications in computer vision. There are many more, such as face alignment, styles transfer, emotion detection, and awareness detection, which I mentioned a bit earlier. So with all of these interesting and useful computer vision tasks, it leads to the third reason to why you should learn computer vision, which is that it is applicable in many industries. There are, for example, in the security sector, people use face recognition to identify criminals and identify wanted suspects. There's also face anti-spoofing, where we can teach a computer to recognize whether a face on an image or video is real or fake. In agriculture, there are plenty of useful applications, such as weed and disease detection, which is a system that can automatically categorize weed and what type of weed it is, and whether the farmer should act on destroying that weed, as well as also detecting diseases on crops. The second application is crop monitoring. This is mainly similar to disease detection, where farmers can have like a visual system that can track whether a crop is growing at the right pace, or is experiencing any disease, or maybe a lack of sunlight and all that. There's also usage in livestock monitoring of animals like chicken, cows, pigs, and all that. I've also seen application of computer vision in yield prediction, where scientists try to predict the chances of crop being able to grow on a soil by just the picture of that soil. The last application in agriculture, which I think is interesting, is crop sorting and grading, where you teach a machine to automatically sort crops and give a rating to that particular crop. I've seen people use it with tomatoes and pumpkin. Aside from applications in agriculture, there are also applications in entertainment. Mostly, I see computer vision used in augmented reality, such as those you've seen in Pokemon Go and um, in Snapchat and Instagram filter, the ones that I talked about earlier. There's also computer vision technology used in football, particularly for goal line technology, where computers are used to predict the trajectory of the ball and on the goal line in order to show the projection to the referee, so that the referee can make better decision on whether the ball passes, uh, whether the ball is considered as a goal or not. There's also application in image and video enhancement, such as things you've seen um, in TV shows, in crime TV shows, where the police is able to enhance a criminal's license plate. Uh, it's not quite at that level yet, but there are models that can upscale an image from a low resolution to very high ones. And in addition to that, computer vision is also mainly widely used in CGI, in movies and TV shows. Aside from entertainment, another widely used computer vision industry is the robotics industry. Particularly, the most famous ones are self-driving cars and autonomous drones. We've seen this used by Amazon, where they delivered packages to people doorstep automatically using drones. And for self-driving cars, even though it's not in our country just yet, but in developed countries like the US, it is now a widely used technology. In addition to those consumer-friendly products, consumer-friendly robots, CGI, computer vision also used in industrial robots as well, for things like automatically wielding a car door in an assembly line, or separating uh, separating bad plastics from good ones. So these are a lot of interesting applications, and um, computer vision skills can be applied in all of these industries. So those are the three major reasons I think you should learn computer vision. And after knowing these three reasons, I want to talk a bit about how you can start. So what I did in order to start learning computer vision was first getting some of the math basics down. So the math basics that you need to know, I believe, are linear algebra, calculus, and probability and statistics. Now, you don't need to be an expert in all of these fields. You just need to know enough so that you are able to do more research if you are not familiar with some of the topics. The reason why you need to know linear algebra, calculus, and probability is because a lot of the focus of computer vision today are mainly through the lens of deep learning, and therefore these three mathematic areas are essential in deep learning. After you're getting the math basics down, the next step that you can take is to get some basic programming down. So if you haven't had any programming skills before, you should start with Python because it has a very easy learning curve, and it is also widely used in the computer vision community. And so after you get all of after you know some basic programming and mathematics, you can start building projects using open source frameworks. Now, these framework includes things like OpenCV, TensorFlow, PyTorch. These frameworks will help you build your project and treat some computer vision models or machine learning models as a black box, so that you don't need to worry about the concept, but you will still be able to produce a finalized product as well. Um, by doing projects using these frameworks, you will get a sense of how computer vision applications are built, which is essential in keeping you motivated to pursue this field further. And with that said, um, learning this framework alone will not let you go far in the computer vision field. You will need to learn the concepts within computer vision as well. And therefore, the final things that you will need to learn is to go deeper into the concepts of computer vision. And those include image processing, machine learning, and deep learning. These skills of these concepts are used widely across the computer vision field. And so by learning all of the concepts in detail, you will be able to know whether your implementation would work, or whether you need to modify certain things to make it work, or you will be able to analyze certain problems and match it with a certain solutions that are available in computer vision. And I think that if you follow these 4 steps, you will be able to at least get a grasp of how computer vision works and able to generalize on your own and find your own path to pursue a career, if possible, in computer vision as well. And I believe that is all. Thank you for listening. If you have any questions, you can ask. I will gladly answer them. No, you don't need to be an expert in math to be able to pursue a career in computer vision. The reason why is that, as I've mentioned, you only need to know the basics in order to build upon those basics, right? Uh, in a lot of the time, you will be using tools that are already implemented for you. But by having the basics in math and programming, you will be able to dig deeper if you want to into those frameworks and into the tools that are provided for you. So far, the projects that I've done include, I would say, I've done around 10 personal projects, while there are other projects that are being implemented at work. One interesting thing that I've implemented personally was the head pose estimation that I've talked about earlier, where you can teach a computer to actually to be able to predict the angle of a human head in an image. So that was an interesting one. Yes. Uh, in computer vision, uh, you will need a lot of data because uh, as of right now, a lot of computer vision models are relying on convolutional neural networks, and those kind of networks need a lot of data in order for it to work properly. And so, a lot of the time, you will need to collect as much data as you want, and sit down, label it, or have other people label it for you, and you will be able to train a computer vision model with with those data. Hmm. I would say that for the field of ML in particular, I I wouldn't suggest you go with a book from the start, because I would rather suggest courses instead. If you want to get started in machine learning or computer vision in particular, because textbooks are very detailed uh, with teaching you the things in those fields. So you would probably lose interest after reading a few chapters. So I would suggest you first get a course that teach you computer vision or machine learning. Uh, since you are since you are, I believe, a Paragon student already, you would already have access to Coursera. There are quite good courses in Coursera, particularly the one from Stanford by Andrew. By Andrew. Mm, is there any chance that machine learning could become big in Cambodia? I believe so. It is it is a growing field, even though it's not even though it might not be a skill that is in demand in the next 2 or 3 years. It could be a skill that will be very in demand in the next 5 years or 10 years, which I believe is a good thing. It's similar to I would say that it is similar to web development. The progression of web development in our country. It took around 10 years for web development to be this popular these days. A lot of like programmers tend to go for that route. Sure. There are courses on YouTube that teaches you machine learning and computer vision. But I believe if you have a more structured way, a more structured uh, way of learning, it's better, because most of the time on YouTube you would just go in and watch random videos relating to the topic, which might get you more confused rather than teaches you about the field. So I still believe that you should take a course in Coursera so that you get a more structured way of learning and get an overview of the field. And after that, find a project that you can do. And if you want to learn deeper into some concepts, then you can get a book or read an article about it or read a journal paper about it. Right? There any more questions? If if no, I'd like to ask everyone a question. Most of you see us students or like, from other departments as well? I see. So yes, you have quite a lot of time to actually pursue the if you are interested pursuing the field of computer vision. Uh, so I want to stress this again. In the computer vision field, you don't if you want to get started, you don't need to be an expert in mathematics because a lot of the time I see people get scared away from the field, from machine learning and computer vision because of the math that are involved. But I suggest you get started, even though you have little math skills, you can still get started and learn those math skills along the way.
I have a question. Are there like prerequisites or prior knowledge in order for you to learn more about ML?
Well, there are no other prerequisite other than from like I mentioned earlier the basic math skills and programming skills. Since in order to build computer vision applications, you would need to first knowing how to manipulate data uh, and knowing how a computer vision model would work. So these two things involve data manipulation. You would need some programming skills in order to achieve that task. While understanding the computer vision model would requires a bit of math skills. So I believe if you have those two things, it would you would be able to proceed forward within the field. How can we collect data or get the data that you can use in those? It depends on so the data collection process uh, depends on the machine learning model or the computer vision model that we will use. If you, for instance, if you want to be able to have a computer find a dog in an image, you would go around and take pictures of a lot of dogs and a lot of different types of dogs. After which you will sit down and uh, label the images um, using tools that are open source. You can label the images saying that, oh, in this image, here from this coordinate to this coordinate is it's the dog. So you will do this for if the amount of data that are required depends on the model that you use. And if you when you use a model, you will be told how much or how much data you have to collect. If not, you will have to just uh, do a trial and error where you have to collect data little by little and increase the size based on that. Now, working as a freelance, okay. So my freelancing work steals away a bit from what I do full time, which is a machine learning engineer. My freelancing work mostly involves building mobile applications um, relating to front end applications, front end mobile apps. And so most of the time, people would just contacting you through referral. Um, I've uh, I've rarely have clients who actually approach me out of the blue. The clients would contact me for projects through people I know. Right? So maybe a good takeaway from this is that make a lot of friends and people will refer you to projects.
Feel free to ask more questions.
So there's one thing that I like to add. In computer vision, most of the time, uh, the amount of time that you spend writing code for the model is a lot fewer than the time you spend collecting data and labeling it and manipulating it, pre-processing the data to work with your model. And these steps are not just a single cycle, a single flow. It is a recurring process. Right? You start with data collection and you run it through uh, you manipulate it, you feed it into your computer vision model, you test out the result. If it doesn't work well, you try to figure out what's wrong with is it the model or is it the data? If it's the data, then you go back, do the data collection process again, and you start the entire flow again. So most of the time, the majority of the time spent with data collections and pre-processing. There's a saying that if your data is not good, then the output will also not be good. So to be good in machine learning and in computer vision, you need to be able to know exactly what data you need and how you can manipulate it in a way that will produce the best output for the particular algorithm that you use. So my recommendation is uh, first to know how you can proceed with learning a big field such as machine learning and computer vision, because there are a lot of things that you can do, which if you dive in head first, you might get confused and leave and decide to not going into that route. So I believe it would be best if you know how to do things little by little, and by that I mean you should start first by doing projects, and the more projects that you do, the more the more you are exposed to that field, and only then will you know which direction in the field that you like. In So the math that are used in machine learning and computer vision in particular are uh, linear algebra, calculus, and probability. Uh, Again, I stress this again. It's unless you want to be a researcher in the field. If your plan is to be a researcher in computer vision, only then that you need a very in-depth math skills in those areas. If your goal is to just be a people who can implement computer vision model, can uh, who is able to work uh, with existing models, then you only need to know some basic levels of it. For instance, in linear algebra, you just need to know how matrix manipulation works, uh, how to do how dot products are performed, so that you can write when you write code, you will know whether what you are doing with the data is right. Right. Are there any more questions?
anything else? People, guys? Okay, or maybe some of them are shy to ask questions. So if you have more questions, then you can just contact Mr. Socret, right?
Yes. Yes.
So the contact details are posted in the event page. Maybe you can just check that.
Okay. So yeah, don't hesitate if you want to contact me and ask me questions, you can. Uh, I will be happy to
Yeah, I
answer.
guess. Yep. They will have questions soon, maybe. Or maybe when they reach their junior or senior
Yeah.
university life, maybe tips, Mr. Secret, maybe you just have this last
Sorry, I didn't get that.
advice.
I'm sorry, can you repeat that? I didn't get to hear properly.
I guess they have question like, are there any tips to get through the university's life as CS students?
Tips after graduate for after graduation.
I guess
Uh,
not. Before.
I'm sorry, I can't hear you properly. Would you mind type it in the message box? Okay, sorry. Just to
Yeah.
get through the uni life. I see. Um, well, as a CS student, a lot of the time, your task would be going to class and having work that you need to complete, right? So uh, during my time studying at Paragon, though even though those things are good, it becomes very repetitive quickly. So I suggest that in order to keep your interest in CS, you pursue some other projects of your own, while also doing your bachelor's in CS at Paragon as well. Because by having your own projects, you are more likely to be exposed to other topics that are not introduced in schools, and those topics might be of your interest in the field of CS, right? So I guess my tips to get through university life as a CS student is to basically do projects so that you keep feeling motivated, you keep feeling interested in CS throughout the 4 years.
Okay, I guess I have no more questions. You have a meeting at 10 o'clock, right? Mr.
Yes,
Secret?
yes.
Okay, thank you so much
Okay.
then.
Yes. So
Yeah.
yeah, thank you for listening to me for 1 hour.
Yeah, thank you so much for your time and thank you for sharing your knowledge.
Okay.
It's I guess it won't stop here because our students will be asking more questions. I guess they will be sending more questions.
Yes. You can contact
Okay.
me anytime. To everyone, I will be happy to answer your questions.
Yeah.
Okay, so bye bye, everyone.
Okay. Thank you, Mr. Sacre,
Thank you.
and thank you. Thanks to all our students who participated in this.